This exercise talks about sine, cos and tan of obtuse angles. It really is an introduction to the sine rule. It's really with sine that we have an issue with obtuse angles. Now, and so we've got to get defined the situation when an angle is obtuse, especially when you're trying to take or find the sine of that angle. So remember, obtuse angles are angles between 90 and 180 degrees, and there is a connection between angles of that size and an acute angle. Some of you may have been exposed in year 9 or 10 to a nice little diagram where we talk about angles. In this first quadrant, we talk about quadrants 1, 2, 3 and 4. And by the way, we're never going to, in this course, extend our understanding to angles in quadrants 3 and 4. But here in quadrant 1, they're acute angles like this. So it's sort of like all the angles have this as a common arm of the angle. So in quadrant 1, they're all acute. And what we know about the trig ratio of any acute angle is that they are all positive. Over here in the second quadrant, our angles now become, and maybe I'll just change colour, our angles now become this size, which we label as obtuse, and only some of them, which is the sine, is positive there. Like I said, some of you may have been exposed to that with a T there and a C there and have learnt the little rhyme, all stations to central. If you have been exposed to that, you will know that sine is all, the sine of an obtuse angle is positive, which then means that cos and tan of obtuse angles is a negative number. So we're going to pursue the two things, the sine of the angle, whether it's positive or negative, which we already know from this little rhyme, and the connection between an obtuse angle and a corresponding acute angle. So like it says here, there is a connection between an acute angle, theta, and the obtuse angle, 180 minus theta. So if, for example, we took 40 degrees as our acute angle, then the corresponding obtuse one in this format here is 180 minus 40, which is 140 degrees. So you can see in the table I'm going to look at 40 and I'm also going to look at 140. And you can hopefully now see the reason why I've chosen those two numbers for the table, because there's this connection between the acute theta and 180 minus that. 60, you know, is another acute angle, and its partnering obtuse angle would be this 180 minus 60, which is 120 degrees. And again, you can see that I've got both 60 and 120 in the table. 85 would be 180 minus 85, which is 95. I didn't put that one in, but you can see that I have put in 80 and 100. Why? Because they're the two angles, one being acute, the other being obtuse, that will have a connection. So what I would like you to do now is to pause the video and fill out the table of values by using your calculator. Simply go to your calculator and ensure that your calculator is in degrees, TEG on the screen, and find the sine of 40 and the sine, and you can do them in pairs if you like, sine of 40, sine of 140. Then sine of 60, sine of 120, sine 80, sine 100. I'll pause the video and do likewise, and then we can come back and compare tables. Okay, so hopefully your table is the same as mine. Now, what can we see? You can see that the sine of 40 and the sine of 140 were the same values. The sine of 60, you got the same value for the sine of 120, and then likewise with 80 and 100. So there, what it's showing is there are obtuse angles which have exactly the same sine as an acute angle. Now this becomes a problem when we're trying to find the angle. So if you simply said that the sine of some angle is 0.6, find the theta, so you would do your sine inverse 0.6, you're going to see that there are two possible answers, because you can see that there's angle 40 degrees and angle 140 degrees both have a sine which is 0.6. Your calculator, unfortunately, will only give you one angle. It will ignore the 140. So it becomes a real problem, and if you're not really looking out and aware that you should have an obtuse angle for your answer, you might be inclined just to write down what the calculator says, which in this case will be 40 degrees, which will be wrong if clearly the situation shows the angle is definitely obtuse, or it might even indicate the angle must be obtuse. So what you will do in that case is you'll take your 40 degrees, and then knowing this connection here, that sine 40 would be sine of 180 minus 40, you can work out 180 minus 40 is 140, and give the correct obtuse sized angle. So please learn these off by heart. Sine, cos and tan of acute angles are always positive. Sine of an obtuse angle is also positive. Now we don't have that same trouble with cos and tan, because the moment you can see by your calculator that the cos, for it to be a negative value, it will automatically come up as an obtuse angle. Tan, it's a little bit different again, and I'll go through an example with you on that. But you can see it's negative. The calculator knows something's going on, but it doesn't always give the answer as you would like. So you can see now that I've completed this, the cos and tan of an obtuse angle is always negative. We saw that in the table. And then I'm able to complete this nice little summary. And please learn this, that sine theta is the same as sine 180 minus theta. Cos of theta is minus the cos of 180 minus theta. And tan of theta is minus the tan of 180 minus theta. So we saw sine 40 is the same as 180 minus 40, which is 140. And it's sine that we have the most problem with. Cos 140 is cos 45 is minus the cos of 180 minus 45, which means it's minus the cos of 135. So it's 135 and 45 that have the connection. Cos of 110 would be tan 110 would be minus the tan of 180 minus 110, which is minus 180 minus 110 is 70. So the tan of 110 connects to the tan of 70. However, you need to have a negative in front of one of them. I'll stop the video there and do the examples in another video.